what I have here is a galvanometer. Now this galvanometer is very, very sensitive to electrical currents. It consists essentially of just a coil of wire with lots and lots of turns in it, so it's really a multiple coil. Each coil, or each turn of that coil reacts to the magnetic field independently of the others, so when you put them all together they react very strongly. And that coil is attached to a kind of a torsion spring, a little spring, so that the very tiniest current that flows through here is going to be detected. Now I'm going to turn the crank here, which will create a voltage and make a current pass through the galvanometer, and you'll see what I mean. Okay, whoop, see, just barely. It's almost impossible to turn the thing slowly enough. Okay, and turn it the other way. Of course, it deflects the other way. Okay, turning it backwards very slowly. Now those jumps you were saying were just because the gears kind of stick and then jump, stick and then jump. But you see that I wasn't turning the thing very much at all. So the very, very tiny current through a galvanometer produces a big deflection of the needle. Now if I wanted to reduce the amount of current through that galvanometer, I could put a resistance in the circuit. And if I put a big resistance in the circuit, then not much current will go through the galvanometer and things will become controllable. I'm not going to actually demonstrate that, but that's fairly easy to do. Now, in a circuit, let's say we have a resistance here and a source here, and we have a current which, let's pretend that this apparatus, this is going to be our ammeter, our current measuring meter. But let's say we remove that and we just have current flowing straight through here. Okay? Now, when we hook up the ammeter, this device, we want it to be such that very little current flows through the ammeter. Actually, the ammeter, I said that wrong. We want practically all of the current to pass through the ammeter. Okay, just very little current change in the circuit. I'm saying this all wrong. Okay, we don't want the ammeter to interfere with the amount of current that flows in the circuit. When we put the ammeter in, we want the current through the circuit to be almost unchanged. In order to do that, we put a very small resistance in that ammeter. Okay, very tiny, tiny, tiny resistance. Just really a piece of wire that has just a little bit of resistance to it. Okay, so that almost all of the current just passes right through the ammeter, passes right through this small resistance and keeps on going around the circuit. Okay, now in parallel with that we put a large resistance. Now the current is practically all going to flow through the small resistance. Okay, there's going to be very little current through this large resistance. So we have a larger current through the small resistance, a very tiny current through the large resistance. And we can see that because whatever the voltage is between here and here, it's going to be a very small voltage because we have a very small resistance here. And across that small voltage, the small resistance will take almost all of the current. The large resistance will take just a little tiny share. And that little tiny share that goes through the large resistance is also going to be passed through that coil and magnetic field, essentially through a galvanometer. The result being that that very sensitive coil will register this very tiny current. And of course this very tiny current will be proportional to the voltage across here, which is proportional to the current that's actually passing through the circuit. And that's accomplished with this small resistance, changing the current in the circuit by only a very tiny amount, so that the current that we measure is essentially the current that's flowing through the circuit. Now we have different scales on some ammeters. When you switch the dial from one scale to another, the ammeter you got with your kit has only one scale. It's a 150 milliamp scale, so it's fixed. We just have that one resistor. But there might be 3 or 4 resistors for different scales. We might have one that goes up to just from 0 to 1 milliamp, and from 1 to 10, and from 10 to 100 milliamps, and 100 to 1,000 milliamps. By turning the dial, you just switch to a different resistor here. Or maybe you do some combination of changing this resistance and this resistance, but usually you just change the large resistance. Actually, I don't know, come to think of it. I've always assumed you change the large resistance. I can think of reasons why you might want to change the small resistance instead. But by changing one or another of these resistances, just by changing the ratio of these resistances, we can determine what ratio the current will go through this coil, and then we can just set up our dial with a scale to measure that current. And that's basically all an ammeter is. So there's your basic definition of an ammeter, and that's how the ammeter works.